Hello everyone. In this series of videos, we will be discussing the solutions in details to the problems of Physical Sciences paper of West Bengal SET exam 2022. The question booklet series is X. There are 100 problems in total. We will discuss the first 10 in this video. If you find a better or quicker way to solve these problems, please let us know in the comment section. Let's get started. Let's discuss these problems together. In the first problem, we are given a 2 cross 2 matrix M and it is invertible under matrix multiplication. We have to find its inverse. Let's calculate the determinant. Determinant is x square plus y square. So either A or B is correct. Now let's find the 1/2th element of the cofactor of the matrix. So it is minus of this term, so that is minus y, and now you have to take the transpose of it, so minus y will go here. So option B is the correct answer. In problem, we have to find the value of this integral. The delta function is equal to 1 when the argument of this is equal to 0, that is when x is equal to minus 3, but minus 3 does not lie in the limit of this integral, which is from 0 to infinity. So in this limit, delta function will be always 0, so the integral would be 0. Hence this is our correct answer. In the third problem, we are given a function f of x which is 1 only if x is greater than 0 and less than pi, otherwise it is 0. We have to find the Fourier series expansion of this function. So we know f of x can be expanded in Fourier series as follows: an cos nx plus to infinity bn sin nx. So let's find a naught first. A naught is given by 1 by pi integral over 0 to pi. The function is 1 and dx, so it is equal to 1. So the first term would be half. So let's look at the options. So either B or C would be correct. So let's find B of n. B of n is given by 0 to pi sine of n pi n of x dx, and the integral is equal to minus of cos of nx divided by n. So let's find this out. So this would be 1 minus 1 to the power n. So when n is even, that is n is 0 to 4, minus 1 to the power n is equal to 1. So this term vanishes. So the odd terms will survive only. So option B is the correct answer. In this problem, we are given a 4 cross 4 matrix and we have to find the true statement out of this 4. So we observe that the columns are not all linearly independent. In other words, the second column is obtained by multiplying 2 to the first one, and the third column is obtained by multiplying 3 to the first one, and the fourth is obtained by multiplying 4 to the first one. Hence the rank of this matrix is 1. So there is only one non-zero eigenvalue. The other 3 are 0. So the eigenvalues are 0, 0, 0 and lambda. To find the value lambda, we find the trace of this matrix, which is equal to 1 plus 4 plus 9 plus 16, which is equal to 30. So the eigenvalues of this matrix must satisfy an equation that looks like this. So the matrix A itself must satisfy this. So we found a to the power 4 is equal to 30 a cube. So option D is the correct answer. In this problem, we had to find the second derivative of the Dirac delta function. So note that the definition of Dirac delta function is 1 by 2 pi integral from minus infinity to infinity e to the power I xy dy. Now when you take the second derivative of the Dirac delta function, so you essentially taking down I y factor twice, so which simplifies to minus 1 by 2 pi and integral y square e to the power I xy dy. So the first option is the correct one. if A is both unitary and Hermitian, what would its determinant be? We use the following theorem. Determinant of A is equal to product of its eigenvalues. Since A is Hermitian matrix, the eigenvalues would be reals. The product of real numbers are also real. So that means determinant of A is a real number. This eliminates the last option and the second options. Now we use the fact that A is unitary. Since the eigenvalues of unitary matrix has modulus 1, so there are two possible eigenvalues, 1 and minus 1. And the determinant would be product of 1 and minus 1. So this could be 1 or minus 1. So option C is the correct answer. In this problem, we are given a complex function f of z, and the upper bound of f of z is 16 everywhere on the circle given by absolute of z is equal to 2. We need to find the upper bounds of each of these coefficient a0, a1 and a2. We will use the Darboux inequality, which says that the contour integral of fz along a contour C has upper bound m times L, where m is the upper bound of f of z. In other words, f of z is less than or equal to m and L is the length of the contour C. Now, since f of z is a polynomial in z, each of the coefficient a n can be found by taking derivative of f of z, and derivative of f of z can be found by doing the contour integral as follows. So we will use this formula to find the upper bound of each of these coefficients. Let's put n equal to 0 and find the upper bound of a naught. So the upper bound of a naught is equal to modulus of this quantity, which is 1 by 2 pi and modulus of f of z and divided by r and 2 pi r. So this is the upper bound of dz, this is the upper bound of mod of z, and this is the upper bound of f of z. So let's find these quantities. So 1 by 2 pi, m is 16 in our case, r is 2 and 2 pi times 2. So this thing cancels out. We found the upper bound is 16. So one of the two options may be correct. Let's put n equal to 1 and find the upper bound of a1. So a1 is less than or equal to 1 by 2 pi, and again we use the same thing but putting n equal to 1. So we have r square times 2 pi r, which is equal to m by r. So 16 divided by 2 is equal to 8. So it looks like the third option is correct. Let's go on and find the upper bound of a2. So a2 is less than equal to 2 pi and m r cube 2 pi r. Again cancel out, simplifying the things, we have m by r square, which is 16 divided by 2 square is equal to 4. So option C is the correct one. In this problem, we are given two vectors v and w, and we have to calculate the second derivative of v cross w at this point. So before solving the problem, let's look at the options first. We observe that the ith component of each of these options are different. So we can calculate the ith component of this quantity to figure out the correct answer. Let's find v cross w and its ith component, that means the first component. The first component of this cross product is minus y times minus xyz minus xz times x, which simplifies to xy square z minus x square z. Now we take the derivative with respect to y. This term drops off and this term gives 2xyz. Now we take derivative with respect to x, so this simplifies to 2yz. Now we put the values of y equal to minus 1 and z equal to 2, which gives me minus 4. So option C is the correct answer. In problem 9, let C be a unit circle traveled counterclockwise. We have to find the value of this integral. So we will use Stokes' theorem, which says that the contour integral of f over a closed loop is equal to the surface integral of curl of f. We have a situation where a unit circle is located around the origin and it is traveled in the counterclockwise sense. The unit direction of the area associated with it points along the z-axis. So we have to find the z component of curl of f. So let's find that. Till x till y till z, and we write the component of this vector just underneath of these del operators and find the z component of curl of f. We find that it is equal to 3x square plus 3y square. In polar coordinate, this is 3r square. Now we do the surface integral of 3r square. Surface element would be 2 pi r dr, since this quantity does not depend on theta, and the integration limit would be 0 to 1. So let's do this integral. This is 6 pi times r to the power 4 divided by 4 and evaluated at 1 and 0. So this simplifies to 3 pi by 2. So the first option is the correct one. In this problem, M is a 3 cross 3 matrix such that it transforms these vectors in this way. We have to find this quantity. So we first write this column vector in terms of these two. So one can see that this is equal to 2 times 3, 4, 5, which is equal to 6, 8, 10 minus 0, 2, 0, 1, 2, 0, 1, 2. Now we apply m on both sides of this equation. So m times this is equal to 2 times m times this, and this quantity is exactly 0, 1, 0 minus m times this. This is equal to 1, 0, 0. So which simplifies to minus 1, 2, 0. So option A is the correct answer.